In this video we're going to be talking about intermolecular forces. So intermolecular forces are the forces that hold individual molecules together. They're different from the bonding that holds atoms together within a single molecule. So intermolecular forces are often responsible for holding what's called condensed states of matter together. Condensed states of matter are just liquids and solids. So for example, when water changes from a liquid to a gas, really only the intermolecular forces between the individual water molecules are broken. The individual molecules, the covalent bonds within them, remain intact. So it's a lot easier to break intermolecular forces than the actual bonds holding a single molecule together. So the first type of intermolecular force is a dipole-dipole attraction. Now this occurs when we have molecules with dipole moments. So they can attract each other by lining up their positive and negative ends and then arranging themselves to increase these attractive forces while decreasing the repulsive forces between the negative and negative ends and the positive and positive ends. And this type of attraction gets much weaker as the distance between the molecules increases. So there's a special type of dipole-dipole attraction called hydrogen bonding. Now this is just a very strong type of dipole-dipole attraction that occurs when we have a hydrogen bound to a highly electronegative atom, and this is usually nitrogen, oxygen, or fluorine. So these hydrogen bonds are so strong because the very high bond polarity, and also there are shorter distances between the molecules because hydrogen is very small, so they can get closer to each other. An example of hydrogen bonding is in water, HF, and NH3. So since these hydrogen bonds are stronger than normal dipole-dipole attractions, they have relatively high boiling points. So here you can see a diagram of the hydrogen bonding within H2O. The oxygens, since they have the lone pairs, they are slightly negatively charged, and the hydrogens are slightly positively charged. So the positively charged hydrogens are attracted to the negatively charged oxygens. So in noble gas atoms and nonpolar molecules, there are no dipole-dipole attractions, so they are held together by what's called London dispersion forces. So as the electrons moving around the molecule, they're just moving around randomly, but sometimes they can form a temporary uneven charge distribution. Here you can see the electrons just so happen to randomly clump up on this side, making a slightly negative charge here, and a slight positive charge here. So when this happens, it's called an instantaneous dipole. So these last for a very short time, and remember, they're just caused by the random movement of electrons. So then, once this instantaneous dipole happens, it can induce a similar instantaneous dipole in the neighboring atoms. So since if we have more electrons, then there's a bigger chance of them randomly moving to create an instantaneous dipole. So atoms and molecules with more electrons will have stronger London dispersion forces.